Previously, we used the Addressing for Communication Devices software to establish the addressing for our BSSRT input and output information. In this video, we will generate an EDS file using the XG5000 software, and then import that EDS file into the Productivity Suite software. We will also establish the connection between a P1550 and the BSSRT, allowing the Productivity PLC to control the remote I/O using the data offsets. Let's start in XG5000. This is the BSSRT project we created in our setup video. We are connected to the bus coupler and are in run mode. To generate an EDS file, we simply go to Project, Export Ethernet IP EDS File. This will open the Save As window, and we can select a place to save the EDS. We will save it in the Documents folder, and we will keep that default name of XEL-BSSRT_RX. Once we click Save, we can go to Windows Explorer and see our EDS file in the Documents folder. Great! We are now ready to add it to our Productivity PLC project. I will open Productivity Suite version 4.1.1.10. We will start a new project and select the P1550 as our PLC. We can then click Go to Hardware Configuration. It creates a new project and opens the Hardware Configuration window. If we go to the Ethernet IP tab, on the right side is the EDS file library. There are some pre-install options, but we want to click Import EDS File. Let's go to our Documents folder, and there is our BSSRT EDS. We click the EDS file and then click Select. It added the XEL-BSSRT as a new device, and has version 1.2 of the file available. We can drag and drop it over to the left to create a client connection for this EDS. We will use a structure and call it XEL_BSSRT. Our device name will be XEL_BSSRT as well, and our IP address is 192.168.27.120, since this is the IP address we set for the BSSRT in our video on configuration. Now let's add a message. We click the green plus symbol and we will add an in-out message. Most of the fields will be pre-populated by data from the EDS file, but we want to add a tag in the extended status field. This is technically optional, but most of the troubleshooting for Ethernet IP connections in productivity will be greatly improved by having this detailed information available. We will call our tag BSSRT_extended status. For the message itself, we see there are 3 tabs. Since this is an I/O message, there is input data, output data, and config data. On the Input tab, we need to select unicast or multicast, RPI time, and a data array to handle the information transfer. For this example, the productivity will be the only scanner reading information from the bus coupler, so we will use unicast. Multicast would be used if we had several scanners using listen-only connections to the bus coupler in addition to our exclusive owner connection from the P1550. RPI is determined by a balance of your I/O response needs and your available network throughput. If this number is larger, the lag between I/O changing and the information being seen by the scanner, in our case the PLC, will increase, potentially leading to poor system response. If it is smaller, the system response will be much faster, but the additional messages will increase the load on the network. If this gets too fast, the network can drop packets or even shut down altogether, depending on the networking hardware. For our RPI time, we will leave it at the default of 250 milliseconds. That just leaves the data array for the input information. The BSSRT uses a minimum of 16 bits for each input or output data section, so we can use a 16-bit word array for the data processing. Since our input is set to be 122 bytes in the EDS file, we know we will need a word array of 61 elements, as 122 bytes is 61 words. We will name our array BSSRT Input Array. Productivity will then prompt us to create this tag array before moving forward. We will leave it as a 1D array of 16-bit integer with 61 columns. This will create 61 word elements, accounting for the 122 bytes of input information. Let's run the same setup on our Output tab. We will keep the 250 millisecond RPI and name our array BSSRT Output Array. We will create a 1D array of 16-bit elements and 8 columns to correspond to the 16 bytes of information the EDS requires. We can take a quick glance at the Config Data tab, but there isn't anything to set here as the config data size is 0 for the BSSRT. Let's click OK and it will prompt us to create all the structure tags for the Ethernet IP client properties. We will leave them all at the default and click OK again. We can now see our XEL-BSSRT at IP address 192.168.27.120. Let's close out of that window and choose a CPU for this project to connect to. The AutoScan and Productivity Suite shows us that our P1550 is already at 192.168.27.50. We will select this, and when we accept it, the software asks us if we want to use our PC project or the project already in the PLC's memory. We have just created our project in the PC, so we will select No, Use PC Project. We can then transfer the project to the P1550. Now let's create a data view window for the Ethernet IP information tags we created earlier. The productivity software makes this easy because we can go back into our hardware config, right-click on the BSSRT, and select Monitor in Data View. The software then asks us if we want to create a new data view or use an existing one. We will create a new one. If we now double-click Data View on the left side of the screen, it will open our data view, and our second tab is the BSSRT information. None of the information is populated yet because we haven't initiated the connection. Let's enable the message by checking the box next to MSG1 Enable, and then send that edit to the CPU. We get the TCB connected return. The software populates the adapter name and vendor ID, and the connection online Boolean also becomes true. Let's try and turn on the first output of our digital output card. If we go over to XG5000 and then to the I/O parameters screen, which is already open in our case, we see that the TN32A output card is in slot 2, which is the third slot, and that the first output point is variable %QX0.2.0. Let's add that to the monitor window so we can observe when the module turns it on and off. We will also go into monitor mode, and we see that the output point is currently off. Let's pull up our data addressing tool. We set this up in the previous video, so please refer to it for further details. We see that the TN32A will be at an output address offset of 2. Note that the first address offset is 0, so address offset 2 will be the third address. If we select the module, we see that it stores the output bits as 4 bytes of data, so our first output point will be bit 0. If we selected a more complex module, such as our analog module, this information would detail which bits contain which key pieces of information, such as module or channel status. We go back to the Productivity Suite and maximize our output array. The software starts its array element number at 1, so we will actually use element 3, not element 2, to control the TN32A. Productivity also has a cool feature to allow us to look at the individual bits within a word. We right-click on the element and select Show Bit of Word Details. It breaks out each bit as true or false. We can write a value of 1 to the word, which will correspond to the first bit being on. We send the edit to the PLC, and if we look back at XG5000, we see that sure enough, the output point has changed to on. Let's go back to Productivity Suite and turn that bit back off by writing a 0 to the word, and back to XG5000, and the point is back off. Perfect. Reading information would be the same process, but with the input words. We are now able to control our remote I/O with our Productivity PLC using the EDS file generator in XG5000.